Hello everyone, welcome to the course Structure Analysis. I am Dr. S. Pachaiappan, Assistant Professor, Department of Civil Engineering, Aditya University. So today we are at the 20th lecture of Structure Analysis. Last lecture we are completed the moment distribution method and Kepler theorem of three moment equations. In today's lecture we are going to see influence line diagrams. So in short term it is called as a ILD. So we are going to discuss what is the concept of ILD, how it is helpful, applications and significance of ILD, all those things. At the end of the lecture, students can able to understand the concept of the ILD, significance and application. So this is the learning outcome for this lecture. Let's see what is mean by ILD. For example, so far we are computed the shear force and bending moment values, sometimes the deflection values we are calculated in the property cantilever beam. So you see all these values are a fixed quantity because in a building if you see dead load is not going to vary. Even though live load is varying, but when we are designing the structure we are going to design it for the maximum load. So we are not going to consider in the building the live loads are actually moving. But in terms of bridges, when the vehicle is passing from one end to another end, there will be a moving load. So according to that moving load, the shear force and then bending moment for any point is not constant. It is going to keep on varying depending upon the vehicle loading condition and then location. So ILD is particularly discussing about the moving load concept. Please see, so whenever a system of loading crosses a beam, the shear force, negative as well as positive, and then bending moment at any section of the beam goes on changing. As the system of loading moves from one end to other, we have drawn the shear force and then bending moment diagram showing the maximum value of the functions. For example, you see this is a multi-axle vehicle, the figure I am showing. So each going to contribute the load. For example, let's say this is P1, P2, P3, P4 and so on. So these load when crossing the bridge girder or a beam, then the load, the shear force, bending moment values and then the deflection values will keep on changing. So a deck slab, we need to design the beams for the maximum probable load. So the ILD will give you the idea how to design the structure for the maximum probable loading conditions. So in the modern design office, it is the useful practice to plot the curves showing the variation of shear force and then bending moment for one particular section. So the benefit of the ILD is, first of all, we are going to get the shear force and then the bending moment and then the deflection is the function of x. In the program, when we put the x is equal to 1, we will be getting the shear force, bending moment, deflection simultaneously. So here the variable is just a location where the load is moving currently. So we are going to give the, in MATLAB programming or something, we are going to give the x is a variable 1, 2, 3. So every meter or every 0.5 meters, we are going to get all the responses. So these curves are plotted on the span of the beam as well as the base and then variable function as ordinate at various points along the span. And the variable function may be, as I told you, the shear force, the bending moment and then deflection, etc. Since these curves indicate the extent to which a particular function of a given section is affected or influenced during the passage of loads system is crossing the span, these are known as influence lines. In simple term, I can tell you, when the moving load passes on the bridges, what is the response of that bridge deck in the particular location, that is called the influence line diagram. So the response may be the deflection, maybe the shear force or maybe the bending moment as well. Why it is important, we'll see. So influence lines are essential in the design of structures that resist large live loads. So if you see in the buildings, there is no possibility of large live loads. The live load is only due to the movement of the peoples. Okay. So when we are designing the slab for a residential building or for an industrial building, for a commercial building, we are going to change the loading based on the IS specifications. For example, if it is a residential building, we are going to design the slab for 2.4 kilonewton per meter square. So that is the maximum load we are designing. So whatever the live load, the moving loads of the human being is negligible. We are not going to consider it, right? So but here the large vehicles, one time your military vehicles going to pass on the bridge, and next time residential vehicles, heavy trucks, each and individual vehicles are, the load classifications are different, and then based on the location, the responses will change. Okay. So if a structure is subjected to a live or a moving load, the variation in shear force and moment is the best described using influence lines. So the variation of the shear force, a bending moment or a deflection is effectively captured by using the concept of influence line diagram, that is ILD. So once the influence lines are drawn, the location of the live load which will cause the most significant influence on the structure can be found very quickly. Okay. So what is the advantage? I told earlier, x is the variable. As the function of x, we are going to get the shear force, bending moment and then deflection. So easy to substitute x, instantaneously we are going to get all the responses. So that is a greater advantage of the ILD. For example, you can see here, for example, it is a steel bridge girder, and the top of the girder, what we are seeing is a car is moving in a forward direction. Now you imagine when the car is moving exactly on the top of that this vertical strut B, the maximum forces will be transferred on the truss B and C support. Okay. And the nearby support. So this member will be subjected to the tension. But you imagine when the car is moving further forward, then automatically this member, whatever the member I marked here, it is subject to the maximum loading, it will be get reduced, and then the remaining members is going to take the maximum load. So we need to design the truss or any structural element or the bridge deck for the maximum probable load. So that is the purpose of ILD. So you see here, as the car moves across the bridge, the forces in the truss member change with the position of the car. So x is a variable, and the maximum forces in each member will be different at a different location of the car. So the same member is going to subjected to the very minimum force, at the same time it is going to subjected to the very maximum forces also, depending upon the location of the car. So this case is not at all possible in the conventional buildings. Then the design of each member must be based on the maximum probable load each member will experience. And then if the structure is to be safely designed, the member must be proportionate such that the maximum forces produced by the dead and then live loads are less than the available section capacity. So the section capacity, when we are deciding the Young's modulus and then the material property E value, that should be based on the maximum probable load of the structure. So structural analysis for variable loads consists of generally two steps. First one is the determining the position of loads at which the response function is maximum. So we need to identify which location the maximum responses we are getting. What is the maximum responses? If I keep the load at which location, so that I will be getting the maximum shear force. If I keep the load in which location, so that I will get the maximum bending moment and then deflection. Okay. So first of all, we need to find the location where the maximum shear force or bending moment or deflection is happening. Accordingly, I will design the structure. So determining the position of the loads at which the response function is maximum, that is the first thing. And then the computing the maximum value of the response function. First thing is we are going to calculate the, for example, this is the deck slab or the beam. On the top of that, the vehicle is moving. First, I am going to keep the load somewhat nearer to the support, and then I am going to keep the load at the center and somewhat away from the right support, and then exactly at the right support. So I am keeping the load at the different locations, right? Now, at which location the shear force is maximum, in which location I kept the load such a way that I am getting the maximum bending moment. All this I am going to calculate first location and then the quantity of the shear force and then bending moment and then deflection. So what is the response? The response may be, I am going to calculate the support reaction, axial forces, shear forces, and then the bending moments. So type of influence lines we are going to see in the upcoming lectures. We are going to see ILD for the reaction force. By using the influence line concept, how to calculate the reaction force. By using the ILD concept, how to calculate the shear force, and then also how to calculate the bending moment. So each I am going to take as a separate lecture for a reaction force and a shear force, and then bending moment for easy understanding. So all these concept, how to compute the reaction force and shear force bending moment by using ILD concept, we will see in the next lecture. So in the summary, what we are learned, what is the concept of the ILD and also what are the significance and where and all it is used. So thank you for watching this lecture. Thank you.